Section 6.4, we've been talking about this for the last few days. We said eventually we're going to talk about rectangles, and we talked about it quite a bit yesterday, I think, didn't we? About a rectangle, or it was the other day, I don't know. Remember we did, oops, wrong tool. Let's try this tool right here. Remember we did this, and we said if you have a parallelogram with one right angle, so if this is a parallelogram, you have one right angle, then what must be true about all the other angles? They got to be all right angles, right? Because remember the opposite angles are equal, right? The consecutive angles are supplementary, so that has to be 90. And if this is 90, then this has to be 90. Then we mentioned, now it wasn't really said in the book, but we mentioned, because you guys have heard of rectangles obviously before, and we said, well, what does this look like? Well, that's a rectangle, isn't it? Okay, and it absolutely is a rectangle. So a rectangle is also a parallelogram, isn't it? Okay, so write that down. So a rectangle is a parallelogram. Parallelogram. There we go. Do you sound words out when you write them out? I do. All right, so it's a parallelogram. So what do we know about a parallelogram then? So if this is a rectangle right here, what else do we know about this thing? We know that the opposite sides are what to each other? By definition. Now we talked about this the other day. By definition, they're what?
Parallel.
They're parallel. Remember the word parallelogram? Remember we talked about that? By definition, the opposite sides are parallel to each other. Okay, now we had some theorems. By one of the theorems, what was also true about the opposite sides? These two sides and these two sides. What were they?
Parallel.
We already said parallel, right? They're equal to each other, right? Okay, but by definition they're parallel, but by a theorem that they're equal to each other. So let's do this. Let's mark all this stuff. So since we know a rectangle is a parallelogram, all the stuff that's true about a parallelogram has got to be true about a rectangle. But there's one or two special things about a rectangle that's not true about every parallelogram, okay? But let's just talk about the parallelogram. If this is a parallelogram, then these two are parallel and equal, and what? These two are parallel, correct? And also equal to each other. And you already knew this when you were a little kid, right? You knew that a rectangle was what? When you had the opposite sides were different sizes, but these two across from each other were equal, and these two across from each other were equal, right? Right? If I took a little kid out of middle school and I said, "Tell me what a rectangle is," that's probably what they would say. I really doubt that they would say, "Well, it's a parallelogram with both pairs of opposite sides." They wouldn't go through all that stuff, but they could probably tell you that, yeah, if these two, the two sides across from each other are the same, and these other two sides across from each other, they're the same, that makes it a rectangle. Well, they wouldn't be exactly right, but a rectangle is basically a parallelogram with what? All four right angles, okay? So a rectangle is a parallelogram with what? Four right angles. Everybody got that? That's what a parallelogram is. Cookie, if you would like to relax in the nurse's office, or you could take some notes. So those are your two choices. But not relaxing in here, okay? So rectangle is a parallelogram with four right angles. What else do we know about a parallelogram? We know all that's true. We also know something about the diagonals, don't we? Okay. Write something down. You're supposed to be taking notes. That's what you're supposed to be doing in here. It's not a suggestion. I'm telling you, you have to do it. Okay? So let's take a look at these two diagonals right here. What do we know about a normal parallelogram and diagonals? What do they do to each other? Daniel. What do they do? They're not necessarily equal to each other on a parallelogram, but what'd you say, Nicole? They bisect each other, okay? So you know that this is equal to this, and you know this is equal to this, okay? But here's the new stuff. Everything we've talked about so far is all old stuff, right? We just talked about parallelograms. We've been talking about that the last couple days. But there's one thing, well, there's more than one, but this is the main thing that's true, that's different about a rectangle parallelogram than just a normal everyday parallelogram. We always said the diagonals bisect each other. Okay, but if you take a look at these diagonals, what does it look like they might be to each other? They're equal to each other, absolutely. So let's write that down. Okay, so we remember. So the diagonals of a rectangle Now, they do bisect each other, right? Because a rectangle is a parallelogram, and they always bisect each other on a parallelogram. But the diagonals of a rectangle are a little bit more special than that, okay? This only is true about a rectangle, not about an ordinary, everyday parallelogram. This is only true about a rectangle. That the diagonals, they don't just bisect each other, but they are what? They're equal, or we'll say congruent, okay? So the diagonals of a rectangle are exactly the same. They're equal to each other. Is that true about every parallelogram? No, not at all, okay? On a regular, normal parallelogram, that ones we've been talking about lately, one's going to be longer than the other, okay? But they do bisect each other. But on a rectangle, this is specifically about a rectangle, the diagonals are exactly equal to each other. If I took my ruler and pulled it up here and measured this, they would be exactly the same. Everybody with me on that? Okay. That's really the main difference between all other parallelograms. The other major difference is you also have right angles, okay? So the 4 right angles, that's different about a rectangle, and the diagonals being equal to each other, okay, are different about a rectangle. All right. Let's see what else they say. I was wondering if they did a square in here or not. I don't think they do. I think it's the next section. Let me see. Yep. Well, my goodness. That's all they put in here? All right, they do something else. Now watch. Remember, I told you that this was a rectangle. Now, is there like a symbol for rectangle? Nah, there's not. Okay, so if I call this, watch, A, B, C, D. If I call this thing a rectangle, we don't really have a symbol for it. They usually just write out the word rectangle, or you can shorten it just RECT for rectangle. Okay, but we'd still name it what? A, B, C, D. Excuse me. So if I knew this was a rectangle, what would I know about all these angles then? If I told you, if I sat here and said, see that thing right there? See that 4-sided figure? That's a rectangle. What would you know about this as far as the angles are concerned? I hear mumbling. I don't hear words. What? They're all right angles. Good. Looks like I'm killing you guys. Is it really that bad? Is it really that bad? You guys look like I'm torturing you. If you write stuff down, most of you guys that are falling asleep and have your head on the desk because you're not writing anything, okay? I mean, I just don't see it is really that bad. I mean, I've seen teachers that are just horrible, okay, and just put you to sleep like crazy. But I think I'm being energetic. I think I'm trying to get your attention. Am I not? I don't know. You're making me feel really bad. I'll just let you know that, okay? When I see all this, when I see heads down and everything else, not that you care that I feel bad or anything, but, well, it sure seems like it, because I take it personal. I really, yeah, but I take it personal, okay? I want you to pay attention. I want you to learn this stuff. Because I want you to learn. I want you to get this stuff, okay? It's not like, all right, it's just my job. I'm just going to throw this stuff out there. If they get it, they get it. If they don't, they don't. I don't feel like that at all. I want you to get it. I want you to understand this stuff, okay? And I know, but these are all excuses. They're all excuses, okay? They're not, okay? You got to overcome it, okay? You've got to overcome being tired. You got to overcome the boredom. You got to overcome it, all right? You got to rise above it, all right? You're going to need to learn that self-discipline in your life. So learn it now, okay? Write stuff down, for goodness sakes, okay? I still have like 5 people, after I've chastised a couple of you, are still not writing this stuff down. I don't know what it takes. What should I do? Should I write you up? Should I write you up for not taking notes? Is that what you want me to do, for not participating in class? Should I give 0s for class participation? I'm just asking kindly, and I still have people that have not budged yet. Okay, I'm asking you to get some paper out and to write this down. Okay? I'm imploring you to do it. Okay? Put it that way. Look that word up too. All right, let's keep going. I guess I should have paused that, shouldn't I? That tirade that I went on. But that's okay. The world can hear it. Of course, nobody watches my videos anyway, so nobody's gonna hear it. All right, so where were we at? A rectangle. Okay, so if I told you this was a rectangle, we automatically know that these are right angles, and we also know that the diagonals are equal to each other. So let's just do a quick little example here. I'll just make one up, and let's say that this is E right here. And what if I told you that AE was equal to 5? And I told you it was a rectangle, so you know it's a rectangle. So if I told you AE was 5, and I said find DB, okay? Now watch. If you remember this, if I don't put a little line segment thing over top of it, that means find the measure of dB, finding how long that is. Okay, what is the distance or the length of dB? So here's dB right here. Well, you're thinking, well, how in the world can I find dB? I don't know either one of these. I don't know DE and I don't know BE. But what did we just say about a rectangle? The diagonals are what? Are equal to each other. And they also, it's a parallelogram, so they also do what? They also bisect each other, correct? So if this is 5 right here, tell me something. What's EC? That has to be 5. And you're like, well, that has nothing to do with dB. Well, it kind of does, doesn't it? Because now I know what AC is. What's AC? It's 10. And what is dB then? It's got to be 10. All right? Make sense? So if this is 5 and it's a rectangle, all these parts of that of those diagonals are 5. Does that make sense?
Yeah.
Okay. All right, so that really comes in handy, knowing that the diagonals are equal to each other. You know what they're going to do, though, don't you? They're going to do this. They're going to say this is x plus 2, and this is 3x minus 1, and then you got to solve for x and all that kind of stuff, right? All right, they've been doing that all year long, so you know they're going to eventually do that kind of thing. All right, here's one more thing. Let's do this. This is that converse thing. We talked about a whole lesson yesterday on converse. All right. So what if I had that? Is that a rectangle right there?
No.
Right. Or we don't know, do we? W, X, Y, Z. I mean, it may be. We just don't know. All right. So I can't say no definitively it's not a rectangle. But I can say, though, no, don't know that it's a rectangle. But what if I did this? What if I said, okay, that's a right angle, that's a right angle, that's a right angle, and that's a right angle. What if I told you that?
Yeah.
Now is it a rectangle? Absolutely. Okay? I didn't have to tell you it was a rectangle. You saw the right angles, so that automatically means that thing is a rectangle. You okay with that? Yes.
If you put just the W and the Z, can you know too?
No, because you don't know that these are parallel to each other. Okay, it's a good question, though. She said, if you put a right angle at W and you put a right angle at Z, does that mean that this is a rectangle? No, you don't really know that because, well, actually, let me think about that. No, you don't, because that doesn't mean that this is a right angle right here, does it? I mean, you know, this could be just a little bit off, right? So you don't really know. So you really can't say this is a rectangle with this 2. You got to know all 4. But there's something else you could know. Watch this. If I said, if I told you that WY, now again, I don't know it's a rectangle to begin with, okay? I did not sit here and say this thing is a rectangle. But what if I told you that WY was equal to XZ? These are diagonals, aren't they? WY and XZ. So if the diagonals are equal to each other, what do you think? Then it's a rectangle. Exactly right. It's the converse. Remember doing that yesterday? Because before we said, when we first talked about this, we said, if it's a rectangle, then the diagonals are equal to each other, right? But then we switch it around. We switch the if and then around. And so what would we say now? If the what? If the diagonals are equal to each other, right, then it's a rectangle. It's a rectangle, okay? Not just a parallelogram. I mean, it would be true that it is a parallelogram, but it's not just any old parallelogram. If the diagonals are actually equal to each other, then this thing, this WXYZ, would be a rectangle. Make sense? So if this is true, then we can say it's a rectangle. Rectangle WXYZ. All right? Again, a subtle difference. Remember we were talking about that yesterday, right? So it's a very little difference, but it is a difference, okay? So before we said if it's a rectangle, then the diagonals are equal. Now we switched it around and we said, okay, if the diagonals are equal to each other, then this thing has got to be a rectangle. Make sense? All right. And I think that's pretty much it. And you know what they're going to do on the lessons? They're going to give you stuff like this, and they're going to put X's and Y's and all that. And you got to set things equal to each other and set solve for X and solve for Y and all that good stuff. And you guys should be so used to that now, right? You almost look forward to seeing that. I don't know if I'll go that far, but at least you're comfortable with it though now, aren't you? When you see stuff and you're like, oh yeah, if I set them equal, I solve for X. I think you're pretty comfortable with that stuff now. I hope you are. That's it. So let me give you a worksheet, and you've got some time in class here, even with my little outburst here. You can start working on the worksheet, and then it's due Monday, I guess, right? Today's Friday? Yep. So it's due Monday. You're not going to do every single problem on there. When I give it to you, I'll let you know which problems you have to do.